Hi, this is Sir Amboy and welcome to my YouTube channel. This video is still part of my lecture series in electromagnetics, which starts with vector analysis. In this video, I will teach you how to get the product of two vectors. If you're given two vectors, there are actually two types of products which you can get. One is a scalar product and the other is a vector. Let's start with the scalar product. A scalar product is obtained when you get the dot product of two vectors. It's called a dot product because the symbol uses a dot. So here it is. This is how you write the dot product of vectors A and B. We have A dot B. Vector product, on the other hand, is obtained when you get the cross product of two vectors. Cross product is indicated by the use of a cross, this sign, which is the usual multiplication sign. That's why it's called a cross product. So remember, the dot product is a scalar and the cross product is a vector product. Now, how do we get the scalar product or the dot product of two vectors? The dot product of two vectors is a scalar whose value equals the product of their absolute values times the cosine of the angle between them. Okay, this is how you get the dot product. It's called the scalar product because the answer that we obtain when we get the dot product is a scalar. And sometimes it's also called the inner product. Now, if we are given two vectors, for example, vector A and another vector, vector B, and these two vectors are separated by a certain angle theta. How do we get the dot product of these two vectors? According to our definition here, the dot product of A and B is equal to the product of their absolute values. Okay? So, we multiply the absolute value of A by the absolute value of B and multiply them, because here we have times the cosine of the angle. So, absolute value of A times the absolute value of B times the cosine of theta. So, here it is. The dot product of vectors A and B is equal to AB cosine theta. So, you may notice here that A and B on the left side are printed in bold, meaning they are vectors. But on the other side, on the right side, A and B are not printed in bold, meaning these are just the absolute values of vectors A and B respectively. Okay? So, tandaan po natin yung notation ha. Kapag naka-bold, vector siya. Pero kapag yung vector ay hindi naka-bold, that only indicates yung kanyang absolute value. Okay? Di ba madali lang? So, dito, makikita natin that the dot product has the term cosine of theta. Now, if the angle between the two vectors is 0, cosine of 0 will give us 1, and what will be left is just the product A times B. So, in that case, if the angle between these two vectors is 0, then we get a maximum dot product. Because this cosine of 0 will give us 1, ang matitira na lang is A times B. Diba? But what if the angle theta is not 0? Then if it's not 0, then we can have an answer that is less than the product A times B because the cosine of theta, if theta is not 0, would be less than 1. Okay? Or, if the angle is not 180. Because if this angle is 180, that will be negative 1. Magne-negative lang yung sagot natin. Now, what if we multiply unit vectors? For example, the unit vectors AX, no? AY and AZ. Paano mag-multiply ng mga unit vectors? If we multiply two identical unit vectors, for example, we have AX dot AX, remember, these two vectors are identical. And if they are identical, then the angle between them must be 0, right? And if the angle between them is 0, cosine 0 is 1, and that will give us AX times AX. since ang absolute values ng dalawang ito ay 1 kasi mga unit vector sila, ang makukuha nating sagot ay 1. So tandaan natin ha, that if we multiply two identical unit vectors, the dot product is always unity or 1. How about if we multiply two different unit vectors? For example, we multiply ax dot ay. What do we get? We know that these two unit vectors are perpendicular with each other, right? Because in the Cartesian coordinate system, this is your ax, this is your ay, and this is our az. So all of them are mutually perpendicular with each other. And remember that if they are perpendicular, what's the angle between them? The angle between them is 90 degrees. And what is the cosine of 90? Cosine of 90 is 0. So now we are able to come up with a general rule that if we are getting the dot product of two orthogonal vectors, then the answer is always 0. No? Tandaan natin ha, here the word orthogonal means perpendicular or normal. The word orthogonal is synonymous to the word normal and perpendicular. Lahat sila ibig sabihin 90 degrees yung angle. Okay? So kapag nag-dot product tayo, for example, ay dot az, matik 0 yan. Tatandaan ha, kapag nag-dot product ng parehas na unit vector, ang sagot ay 1. Kapag nag-dot product ng magkaibang unit vector, matik ang sagot ay 0. So, there is a condition for orthogonality ha. Two vectors are orthogonal if and only if the dot product is 0. Now, what if the two vectors are given in three-dimensional coordinates? Okay? So, for example, we are given the three-dimensional vectors A and B, such that A is expressed in its rectangular coordinate system. Vector B is also expressed in rectangular coordinates. So, here, we have two vectors. Both are three-dimensional vectors. Okay, here, AX, AY, and AZ are the vector components. And these small letters ax, ay, and az are the unit vectors. How do we get the dot product of these two vectors? It's very simple. You just multiply all the terms. First, we multiply this term to all the terms here in B. Okay? But if I multiply these two, ax dot ax would give me 1. And I will get a term, this ax multiplied by bx. But if I multiply this term with this, I will get 0. Why? Because ax dot ay is 0. Remember? That product of two different unit vectors is always 0. Likewise, if I multiply this and the last term here, 0 pa rin yun. Why? Because ax dot az is 0. And then I will multiply the second term of vector A to all the terms of vector B. So this term times this is 0. Then for the second term, multiply it here. I will get an answer. Why? Because ay dot ay is 1. So I will get ay times by. No? Now, and I multiply this term with this. The answer is also 0. Now I multiply the third term here with all of the terms in vector B. The product with the first two terms will be 0, and I will get an answer if I multiply these two terms, az, bz. So in effect, if we are multiplying two vectors expressed in rectangular coordinates, we simply multiply their respective components, no? X component to X component, Y component to Y component, and Z component to Z component. You get all the products, and then you add all of them. Like this. Okay, so A dot B is equal to AX BX plus AY BY plus AZ times BZ. So madali lang ha, we only multiply the corresponding vector components and add all of these terms. Okay, madali lang yan, promise. And now that we already know how to get the dot product of two vectors, let us now find out where they are used. What are the applications of the dot product? Mathematically, work. So this work that I am referring to here is the familiar work in physics. So this work is a dot product of force and displacement. Remember that force and displacement are both vector quantities. If we get the dot product of these two, the force and the displacement, we will get a scalar quantity, which is work. That is why work is a scalar quantity, because it is actually a dot product. So remember that work is the dot product of force and displacement. And since it's a dot product, then work must be a scalar quantity. That's why we have the familiar formula in physics that work is equal to FD cosine theta. That is where this formula came from. It's actually a dot product. Now, aside from finding work, the dot product is also used in the calculation of vector projections. That will be one of our next topics. We also use the dot product to calculate the electric flux, magnetic flux, and electric current. For example, you are given the current density. We can calculate the electric current from the current density making use of the dot product. Likewise, if we are given the electric flux density or the magnetic flux density, we can get their corresponding flux, the electric and the magnetic flux, with the use of the dot product. So these are some of the topics that we will discuss in electromagnetics. Okay, now let us have some examples. Example 1. Determine the dot products of the two vectors shown in the figure whose magnitudes are 3 and 5 respectively. So here is the illustration. We have here a vector which is shorter than this one. So this must be the vector whose magnitude is 3, and this must be the vector whose magnitude is 5. Okay? Here, we have an angle 55 degrees. Okay? And here, we have an angle of 60 degrees. And we want to get the dot product. Remember that if you want to get the dot product, A dot B, okay, lagyan natin dito ng arrow to indicate na vector sila. The dot product of A and B is equal to A, B, times the cosine of the angle between them. Okay? We are already given the values of A and B because the absolute values of the vectors are given, 3 and 5. Okay? So this is 3 times 5 times the cosine of theta. But what is this theta? Now, to get the value of this angle theta, okay, this theta is equal to 180 minus 55 minus 60. Okay, so if you subtract, the answer is 65 degrees. Now, I just copy 65 degrees here. Okay, and with the use of a calculator, we can solve for the value of the dot product. Kasi hindi ko naman mamental yung cosine of 65 degrees. Because of that, I will use a calculator, an emulator. Okay, eto siya. Compute natin 3 times 5 times the cosine of 65 degrees. Make sure that you are in degree mode, okay? Kasi kung naka-radian mode yan, magkakamali ka. So we now get the answer. The answer is, okay, I will round my answer to 2 decimal places. I have 6.34. So the dot product is 6.34. That's it. Ganun lang kadali. Kumuha ng dot product. O, di ba madali lang? Sobrang dali. Okay, now let's have another example. This time, find the dot product of A and B. So here, vectors A and B are both 3-dimensional vectors. Vector A is given as 2ax plus 3ay plus az, while vector B is negative 4ax plus 2ay minus az. And after we get the dot product, we find the angle between them. Okay? First, we will get the dot product. Remember, if you are given two vectors in 3-dimensional coordinates, just like this, what do? To get the dot product, we just multiply the corresponding vector components. So, x to x, y to y, z to z. So, 2 times negative 4, that's negative 8, plus 3 times 2, that's 6, plus 1 times negative 1 is negative 1. So here, we will get negative 8 plus 6 equals negative 2 plus negative 1, that's negative 3. Okay, so our dot product is negative 3. Now, let us find the angle between them. Remember that the dot product, A dot B, is equal to A, B, times the cosine of theta. So this is what we're going to use to get the angle theta. But before we can solve for theta, we need to first solve for the absolute values of A and B. Okay, lagay natin dito the absolute value of A. How do we get the absolute value of a vector? Okay, that's just the square root of the quadratic sum. Okay, so we square 2, that's 4. Then plus the square of 3, which is 9, and then plus the square of 1, which is also 1. Now, evaluating this, we have 10, 14, so that's the square root of 14. Now, we do the same for vector B. Okay, for vector B, its absolute value is, so negative 4 squared is 16, plus 2 squared is 4, plus negative 1 squared is 1. So here, we have 16 plus 4 is 20 plus 1 is 21. So this is equal to the square root of 21. Now, we can solve for the angle theta. This theta is equal to cosine inverse of A dot B over A times B. Okay, lagay natin dito, no? Cosine inverse of the dot product is negative 3, and these two, square root of 14 times the square root of 21. Of course, I cannot mentally calculate the value of theta. That's why I have to use a calculator. I-AC natin to. And let's calculate the cosine inverse of, lagyan natin ng fraction sign, negative 3. Tapos sa baba, square root of 14 times 21. Nilagay ko na lang sila sa loob ng isang square root. Parehas lang din naman yan. Okay? Now, we press the equal sign and get, the answer is approximately 100. No? Lagay ko na lang dito, 100 ang sagot. 100 degrees because it's very close to 100. 100.08. But 0.08 degrees is very, very small, no? So, lagay ko na lang dito, theta is approximately equal to 100 degrees. That's it. Ganun lang po kadali. Pero, tuturuan ko kayo kung paano yan gawin sa calculator. Okay? Paano? Ganito lang yan. Mag-mode vector lang tayo. Mode vector. So, mode 8. No? So, kung gagawa tayo ng vector, pindutin lang natin yung 1, no? Kasi, gagawa tayo ng vector A. So, press 1. Now, after that, we choose a 3-dimensional vector, 1, kasi 3-dimensional yan, at i-input natin ang mga vector components. What are the vector components? 2, 3, and 1. So, through 3, and 1. Okay, after that, shift vector, and then we choose data, no? 2. And then vector B. Okay, for vector B, we choose another 3-dimensional vector, 1. Okay, and input the vector components of vector B. So, negative 4 equals, 2 equals, and negative 1 equals. Okay. So, there we have it. We now have the two vectors stored in our calculator. So, if you want to get the dot product, you just recall vectors A and B. To recall that, shift vector, vector A, no? 3. And then, the dot product can be found by pressing shift vector, no? And choose 7, the dot product. Okay? And shift vector ulit to recall vector B. So, 4. So, vector A dot vector B will give us negative 3. Just like what we obtained here. Okay? Now, alin ang mas madali, no? Magmano-mano o mag-calcu. So, kung nakita mo naman kanina, wala pang 30 seconds, may dot product na ako. Pero kung ikaw ay magka-calculator, dun pa lang sa pag-input ng vector sa calcu, aabutin ka na ng 30 seconds, di ba? So, which is more practical, no? Mas practical pa rin yung mano-mano kasi dun mas mabilis mo siyang masasolve. Okay? Kapag nag-calcu, magkamali-mali ka parang pindot dyan, mali yung makukuha mong dot product, no? Pero, itinuro ko na rin sa inyo para alam nyo, di ba? You have an option. Can we also use the calculator, sir, to get the angle? Oh yes, we can use the calculator to get this theta. Okay, remember that's cosine inverse. So to get that angle, we will input the cosine inverse. So shift cosine para makuha mo yung cosine inverse. Tapos ay negative 3. Okay, negative 3. Tapos lagyan natin ng fraction sign. Okay. Tapos lagyan natin ng parenthesis dito ha. No? So yung square root of 14, what if hindi natin alam na square root of 14 pala? Ay di absolute value ng a. Paano gagawin yon? Shift abs to get the absolute value of what? Vector a. So shift vector a. Ayun. And then close parenthesis. Tapos times multiplication sign, no? Absolute value naman ng vector b. Shift abs absolute value of shift vector uli and then vector b. Ayan. Okay. And then parenthesis. Tapos equal sign. Okay. So, nakuha natin yung sagot, 100 degrees approximately. Diba? Ngayon, marunong ka nang mag-compute ng dot product. No? Either using the convention or using a calculator. Okay. So, after this, we will study how to get the cross product.